welcome to my channel where I share my knowledge on programming with Python and OpenCV. Today we're going to continue our color detection series, and we're going to get into binary masking with OpenCV and what is essentially color detection. It's going to be a bit of a long one, so let's get right into it. So here I have a nice little PowerPoint prepared so that I can have my thoughts in order and relay them better to you so that you can learn as best as possible. So, like I like to start, GitHub, I have the link in the description. I've updated the repositories so that for this video, what we're going to be going through is all going to be on there. And what I've added to this repository is the color detector.py module, which contains our color detector class. We're going to get into that today. But I also edited our get pixel HSV value module, and we'll see exactly what we did there to change things, but no, it still works as it did from the previous video. We just have a little bit of additional functionalities. So that's that. So what are we doing today? Well, 3 tasks. We got to understand color masking or binary masking with OpenCV. After this, we're going to see how we apply it in our color detector class. And lastly, we're going to perform experiment together and learn to detect a custom color such as my shirt. So let's get into number 1. A lecture on understanding binary masking with OpenCV. So step 1 to binary masking. We are working in the HSV color space. So the first thing we got to do no matter what is convert our input frame or input image into the HSV color space. We do this using the cv2.cvt color method, and we convert the frame from PGR to HSV as specified in the parameters. That's step 1. Step 2. Once we have our image in the correct color space, we're going to identify the color we want by thresholding the minimum and maximum values in which can represent that color under specific lighting conditions, because this is HSV visibility. And then we define these as our upper and lower bounds. So we threshold a range of values that could be this color, and then we get the maximum set of HSV values that could be that color, and the minimum. That's what we're doing to threshold. So these are the bounds for the range of pixel values that can represent the specific color of the object. So how do we do this? Well, we do this by first using our get pixel HSV value script, and we use this to output a range of HSV values. And then we can use this range and essentially get the minimum and maximum of all of those values. Now, I've got a little note here. We modified the HSV pixel value script so that we can go ahead and just click on our object, and once we close out of the window, it'll output those minimum and maximum values for us. Now, that's the programmatic way. We could also use ChatGPT to help us. So, say we get our range of values using the script, instead of using a function to calculate those minimum and maximum boundaries, we'll go ahead and pass the range into ChatGPT, and I have a little prompt that you can use that will make it really easy for them to just output your minimum and maximum. The nice thing about this is that you can play around with it a little bit. So if you get it from ChatGPT that minimum and maximum are such and such for blue, and you try to detect your custom blue object, but maybe it's not detecting the lighter shades of blue or the darker shades of blue. Well, you can tell ChatGPT that, and in response, it'll adjust this range to include either the lighter tones or darker tones. That's why I like that approach, but you can also use code. We'll see that. Here we are. So, what did we do to modify our getPixel HSV value script? Well, we added a values array variable. It's empty at the top because in our onMouse function, right after we click the pixel, we get that left mouse pixel position, and then we get its HSV values. We're going to append the HSV values for that pixel to this values list. And this works in such a way that we'll, well, let me go back here. So, values.append HSV pixels. It's implemented in the main method as before, but this is the new function. And you might not exactly know where this is going to be seen, but we'll see in a second. So, it's called getThresFromVals, and we output an array. What we essentially do is we get the minimum and maximum hue, saturation, and visibility values using the NumPy's minimum and maximum methods. After that, we go ahead and specify the lower color as an array of these 3 values, and the same for the upper color. color boundary. After that, we print them and we're going to return them. So where do we call this? Well, we call it in our video streaming loop. So we open our capture object and we do everything as before. But if you remember now, so all the whole time this video stream is occurring, we have our while true loop, and we're appending anything we click with that left mouse button to that values array. Now, what we added here is after we press the Q key to break out of the window, we're going to release the capture object and destroy the windows as usual. But then after that, the last thing before our program terminates, we're going to specify our low and up variables. We're going to set them equal to the get thresh from vals, and we're going to pass in vals, which was defined at the top of our script. Now, this is linear programming, so we had to define that at the top. If we define it anywhere else, or anywhere after the onMouse function, it wouldn't work. It wouldn't know what the list is. It said it's non-existent. We got to define it first because it's linear, or sequential, I should say. It's a little different from how we do modular programming. I like to do modular programming and the linear or sequential because it's good to understand both. You can debug a lot better and see the bugs a lot faster when you practice both kinds. So that's our additions. And here we see the output of this. Press the Q key after clicking a bunch. It prints the lower bound and upper bound. Nice. So you could also use ChatGPT as mentioned, and I've already discussed why this is nice because you can use ChatGPT to adjust the upper and lower bounds based on if you want lighter or darker shades. So I'm going to skip that. And we'll use this prompt later, right here within the quotes, to perform our experiment together, and we'll see how it compares with the programmatic approach. So after we get our thresholds, we have to add them to, or we have to define them. So you'll see, and once we look at the color detector module, we have a dictionary that is a part of the class, and we specify as color ranges, where the key is the color's name as a string, and the value is a set of two arrays, with the arrays being the minimum and maximum bounds for that color. We'll see this in a minute. I apologize if it's any bit confusing right now. So at this point, we have the upper and lower bounds. Now, again, note, you'll understand better once we see the class in PyCharm. But what we do in PyCharm is we check if it is a color that we've actually initialized, and if it is, we're going to go ahead and assign these as our lower and upper colors. Now, step 3. With the upper and lower bounds, we have to create a binary mask. We use this using OpenCV's inRange function. Now, in this function, we pass HSV image and these upper and lower bounds. This returns our color mask image. As you can see here, the output is our mask variable, and it's essentially a binary mask with the pixel values within the upper and lower bounds being set to white and all others being set to black. Now, how is this going to correlate to actually displaying the colors? Well, we're not going to be showing the mask. We're going to apply the mask to our video frame. We use that using bitwise. So we use this OpenCV's bitwise AND function, which uses a logical AND operator to perform bitwise operations on the two images and apply the mask. A little complicated at first, but let's go in and break it up a little more. See the line of code, we have a results variable, and we use this to store the results of our bitwise operation. And we perform our bitwise AND operation on the frame. Now the frame appears twice here for a very specific reason we'll see in a second. And then we define the mask argument, and we set equal to the color mask, which we created right here. So now that's the general. Why do we need to pass the frame twice? Well, first let's see. This is what the output is. So what we get is we get the colors in which our mask had white values populated with the color that was detected. Yeah. So this function requires two source images, being the reason we pass the frame in as both parameters. So I have a couple little keys here from Stack Overflow. If you look at one here, self.frame, self.frame, that's kind of the confusing part. This is to apply bitwise AND to the images from the first two arguments. That might be confusing still. Well, you might not know a lot about logical operators or bitwise operations, but really you just need to know about bitwise or logical operators. And here is a little bit of description on the bitwise AND operator. And really the important part is that it takes two equal length binary representations. It's required. It's a comparison. So when you do an and, or, not, there's a few other operators. They're all logical operators, but they typically all require two inputs. And since we're performing the and on the one image, we have to pass it twice. If we were doing image overlaying, we would overlay one image by passing it as our source 1 or source 2 argument on the other image by passing it as the other source. Again, I hate to make it more confusing, so let's just move on. That's the procedure. Let's review. Convert to HSV color space. We get our upper and lower bounds from a range of pixels by thresholding the range. And then we create a binary mask and we apply it to our frame using bitwise AND operator, which is OpenCV's bitwise AND function method. Now, let's see how this is applied in the color detector class. Alright, let me just clear all this out of the way. Alright, color detector class. Let's start at the top. So we have a comment. Here's a reference link right here. You can go to see the basic example of how it's implemented on OpenCV's documentation. And into the class. So we use OpenCV and NumPy, and we define the class as color detector. And then we define our color ranges dictionary, which is an attribute of our class. We define this right here. Now, like I said, the keys are going to be a string representation of our color, and the values for each key is a set of two arrays, being our upper and lower bounds, bound through thresholding. Now, we have three methods if you're including the initialization. The initialization, we just initialize the class with a video source and the frame set to none. After that, we have a method to create a color mask for the specified color range based on, or for the specific color based on the HSV range. Lastly, we have a run method, and this will basically process our video feed and be our entry point and exit point for the application. So let's go through. Initialization, self-explanatory. Initialize the video source and frame set to none. And we have our create color mask. This is where we're doing what we covered in the lecture. So we're going to perform exception handling and do this in a try block. We convert the frame to the HSV color space, and then we're going to check and ensure that we've specified the upper and lower bounds in our dictionary using this if statement right here. Now, if it is in the color ranges that we have as a part of this class, then we're going to go ahead and get the lower and upper color and assign it to the variables by referencing the value of the color ranges for that key. So that's what this is here. Self-tick color ranges, that's referring to the class attribute being our color ranges dictionary. And by calling on the color, that is the key. So if this key is in there, we want to get the two values, which are our arrays lower and upper. Now, if this was not occurring, we're going to say it's unsupported. That way we know we need to define it in the dictionary. After that, we create our mask using the in range, and we apply it using the bitwise and operator, and we return that as our result. Lastly, we have our application method. We're going to do it in a try catch block, of course, and we're going to try to first get some user input. We're going to indicate, please enter the color you'd like, and then we'll go ahead and print the colors that are available by printing the keys from our dictionary. Now, we're going to then create a variable called color, and we're going to set this equal to the user's input, and we're going to indicate for the user to specify the color mask. After they've specified this, we'll state what color they've specified, and we're going to begin processing our video stream. We'll get our frame read from our capture object, and then we'll set our frame equal to that create color mask method. And that returns our result, which is that mask applied to our input frame. So we just have to show it then. After this, we create a variable key, which is an integer, and we set it equal to our cv2.wait key. That's our typical video processing, and is similar to if cv2.wait key 1 and oxff equals ordq key. That was a mouthful. It's the same thing essentially, because we check then after defining that, if the key is equal to q, we'll break. But if the key is equal to c, then that means the user wants to change the color mask. So we'll indicate to them, input what color you want to change it to, and if it's in that dictionary, it'll be our new mask. Now, if we break out cap release destroy windows, and that's it. We got a done domain to initialize the class and call that run method. That's really all there is to it. So next, let's perform an experiment together. So what are we going to do? We're going to get a list of pixel HSV values of my shirt by using the getPixelHSVValue script, and then we'll specify the upper and lower bounds both programmatically and with ChatGPT, just to see the use of both. After this, we're going to go ahead and enter that into our dictionary and test it out. So let's do it. So we can exit out of the PowerPoint. We don't need that anymore. Let's go ahead and go here to our getPixelHSVValue script. It's got the modifications I've mentioned, so let's just go ahead and hit run. Clear my webcam. We're going to do my shirt, so I'm going to hit all around it. I'm going to try not to get the buttons because I don't really want those to be included because they're a different color from the primary color of the shirt. So there, we got a range. We have our upper and lower bounds. So let's go ahead and grab those real quick. I'll just copy and paste. I'm slow, so bear with me. So we'll go ahead and call our color custom. That's our key. Now we're going to define a set of our values, being our lower, and then grab our upper bounds. Now let's hit run on our color detector module. Running the color detector module, we are asked for our input. Let's go ahead and detect our custom color. It's applying it. Let's see. Yeah, there we go. Pretty cool, huh? So it works really well. Nice. Let's look at the ChatGPT approach, because why not? So I'll just go ahead and pull it up here. Bear with me again. Okay, there we go. And we'll go ahead. I do need that PowerPoint actually, so let's go ahead and go grab that PowerPoint. Grab that prompt. Okay, so I'm going to copy and paste this prompt here into ChatGPT. We'll make sure to remove that, and then we got to grab the color range still. So, well, let's do a color range again. And if you want, fast forward through this, you'll see the results in a minute. So, get a bunch of these again. Q key. Grab the range and not the upper and lower bounds because we don't want that to be included in our prompt. Now, to ChatGPT, right here's our range. We'll go ahead and just paste, but we got to go ahead and eliminate our upper and lower bounds. Let's hit enter. There we go. So we got HSV. Now I'm going to have to specify to output this as a set with upper and lower bounds. Two sets of two arrays, or actually one set of two arrays. One set of two arrays with one being the lower HSV and other upper HSV. There we go. Now, why is there two? I need just one. There we go. Okay, so let's see. The problem with ChatGPT is that you've got to do a lot of work in your prompts. So let's go ahead and add another. We'll say it GPT. And we'll go ahead and add the one. And then let's get our other here, our upper. We'll see how well it did. All right, let's run it again. And let's specify here GPT. All right, that works too. So it looks just as good as our other. Now again, I like this kind of approach because you can go ahead and use ChatGPT to account for lighter and darker shades if you'd like them included. But you could also do it programmatically. We've got that on GitHub for you. Now let's go ahead and press the Q key here and see if there's anything else I'd like to talk about. Well, that's it there. Okay, so that's pretty much it. We performed binary masking, aka color detection, using OpenCV. We looked at a couple approaches. Now, I'd like to leave you with some reflections on what we've learned and the process we've been going through. When you implement binary masking, as we did today, you gain a fully rounded view of how things work. Why? Well, if you really think about how we started by understanding pixel color representations and why we use the HSV color space, we can see, looking at what we did today, that this played a crucial role in how we found the threshold values for masking a specific color. And how did this play such a vital role? It did because when we collected our range of values to threshold, these values represented that specifically colored object under the specific lighting conditions we collected the data in. So, we can understand that a machine's understanding of color is far different from ours. Our physical, squishy bodies process so much of this environmental information automatically, with us really having no idea it is doing all of this. Now, a machine doesn't have this luxury, as its perception of the world comes from what we tell it to be. In summary, delving into the intricate tapestry of the physics that govern our existence, and unraveling the mysteries of how our human-machine bodies perceive their surroundings, we empower our machine to emulate this elegant dance. By considering the subtleties of environmental light and understanding how it influences the color of objects, we've equipped our machine to mirror our perceptual prowess. That's right, we've not just programmed a machine, we've harnessed the essence of our understanding to breathe life into artificial perception. That's all I got to say about that. If you liked the video today, please give me a like, comment, share, subscribe, etc. I appreciate your support, and until next time,